Hi, this is Dr. Tech, and this recording is for cisp310, the Tuesday-Thursday class in fall 2018 semester. This recording is about question number 4 of the final exam. Alright, so let's go ahead and do this. So I'm going to display the C code and make it always on top. So this way, we can refer to the C code as we talk about the assembly code. The key of this particular question is to make sure that we understand how to implement various aspects of a subroutine. And let me flip my computer into tablet mode. All right. So there we go. All right. There are, as usual, many ways to implement this subroutine, and I'm looking for a way, whatever way works. Okay. The subroutine itself is recursive because you can see on line 11, the subroutine is calling itself. But it really should not matter because it's no different whether a subroutine is calling itself or calling any other subroutines. So we'll start with the definition of the labels, and we'll start with the label of the subroutine itself, which is RL in this case. So gotta make sure that I got the right color. There we go. So we have RL as the name of the subroutine. In this case, we have two parameters. We have parameter P and parameter param2. So it has no local variables. So we can go ahead and define those things. Okay, so we have return address being defined as 0 because it is 0 byte away from where the stack pointer points to. And then the next one up is going to be parameter P. So this is return address 1 plus. And then we have param2, which is one after that, so it's P1 plus. Okay, so these labels will be helpful later on. And now we're moving on to line 3. Line 3 needs to first retrieve param1, and we want to make sure that it is less than or equal to 1, or we want to compare that to 1. Okay, so let's go ahead and do that part. LDI A param2, and then add AD. So at this point, A has the address of param2, and then we need one dereference to do that, to get to the value of param2. So at this point, A has the value of param2, and we want to compare that to 1, which means we have to load that into another register, let's say B, and then we perform a comparison. So we want to perform a comparison. Using the usual way, there are two ways to do it. One is to implement it as exactly the way it says. Actually, let's do it. I'm just thinking about which way is easier. So looking for param2 being greater than 1 is easier because all the conditional branches that we have can branch when something is less than something else. So it's easier to confirm that 1 is less than param2. So that's what we're going to do. So we have 1 here and then param2 here. And if B, which is 1, is less than param2, then we want to go to the else case. So here we have to be careful because param2 is unsigned. So that means we have to use JCI and not JLI. So GCI to the else label. And then what follows is going to be the then branch. Okay, the then branch in this case is really easy because we just want to use param2 as our return value, and it's already in register A the way I do it here. So there's really nothing to do. So I'm going to do a jump around to the label called end if, and we're done with it. And then the else label is going to be here, and we got a kind of big block of code to do right after the else label. So we're going to do an insertion thing, so I don't have to pre-plan for all of that stuff. And then after the else, we have end if over here. So the end if really has nothing to do. It's already at the end of the entire subroutine, so I can go ahead and return to the caller. So we specify the sequence of code to return to the caller, starting with LD B D, increment D, and then JMPB. There we go. All right. So if I need to indicate the line numbers, which is actually requested in the question, the condition check is everything up to the first conditional branch, which is this part here. So that's corresponding to line 3. And this is corresponding to line 18, which is the very end of the entire subroutine. So now we want to go ahead and implement whatever is from line 9 to line 17. That's a nested conditional statement, starting with comparing whatever is next to what P points to with whatever P is pointing to. Okay, so this is also going to be, it's going to be tedious but not too hard. So we'll do LDI A with P, and then add AD and LD AA. So now A has parameter P, which is itself a pointer. So we don't want to change this too much because we need to get what it points to, and also one past what it points to. So we're going to do one in direction and put it into, say, B, A. So now B is whatever P points to. And then we increment A, do another LD, this time put it into another register. We can put it back into register A if we need to. But since we have enough registers, we'll just use another register here. All right. So now we have register A being P plus 1. We have register B being whatever P points to. And then we have register C being whatever P plus 1 points to. And it's time to compare. So CMP. So once again, it is easier to compare, to confirm that whatever P plus 1 points to is less than whatever P is pointing to. So that's why we are comparing. Okay, I'm just thinking whether I did it the wrong way in the previous one. Nope, I got it right. Okay. So we're comparing C, B in this case. And if it is less than, if C, which is holding whatever P plus 1 points to, is less than whatever P is pointing to, which is in register B, then we'll perform the conditional branch. This one is JLI because the pointer is pointing to a signed integer, so we have to use JLI instead of JCI to perform this branch. And of course, we don't want to use the label else again, but because this is the else within the else, so we can say it's else. Okay. And if we continue execution, that would be the then branch. Okay. And it has to jump around to the end of that if. So that's going to be else. Okay. Bad penmanship here. Let's fix that. So it's going to be branching to else end if this the end if inside the else branch. And then we have the else label defined here. The else label is pretty easy to handle because we have just a return one on line 15, which is the else branch of the else branch. Okay, that's easily done. LDI A1, we'll do that. And then we have else and if defined here. And then this entire chunk of code goes in here. And we also want to kind of indicate the line numbers. So from here to here is line 9. Then we got line 15. This is line 15. And now we just have to, line 9 actually includes the JLI as well. Alright, so now we have the recursive call on line 11. That's the only remaining thing to implement at this point. So we look at that and go like, okay, we need to perform the function call first. Whatever the function call is returning, we will add 1 to it, put it into register A, and that becomes my own return value. Alright, so we need to get back to param2. I don't want to mess around with register A because register, actually, I don't want to mess around with, you're right, I was right. I don't want to mess around with register A because it already has P plus 1 in it. So I can use register B for everything else. Okay, so now we do LDI register B with param2. Add register D to register B. So the register B is now the address of param2, but it is the value of param2 that we want. So we'll do LDBB. So now B is actually param2, but we also want to subtract 1 from that. So that's a decrement B. So B is now param2 minus 1. We'll push it on the stack. Decrement D, ST, D, B. So that pushes param2 minus 1 on stack. So I'm going to comment here, push param2 minus 1 on the stack. And now it's time to push P plus 1, but P plus 1 is already in register A. So we'll just do decrement D, ST, D, A. So this is pushing P plus 1 on the stack. And now it's time to push the return address. Now we can use any register out of A, B, and C because register A is no longer useful to me. So LDIA with dot 6 plus decrement D, ST, D, A. And then we have a JMPI to the subroutine itself, which is RL. So but by the time we come back here, we got 2 parameters still staying on the stack. So it's time to increment D to deallocate those 2 items on the stack. Register A now contains the return value of the recursive call. I need to add 1 to it on line 11. So we'll say increment A. And now that becomes my actual return value. So all of this is implementing line 11. And that goes right here because it is the then branch of the else branch of the entire program. And that's it. That's the entire code. So what I'll be looking for in this case, okay, let me see. The trivial stuff that I may or may not even allocate points to would be the sequence of code to perform the return, okay, because that's really not, It's nothing special. We can copy and paste it from many sample programs that we have done in class. This part here is not worth a whole lot of points. I might give it a little bit because I need to know that you understand the ordering of parameters on the stack. So that's kind of one of the few things that I would allocate points to. And then we have the actual access of param2 and p in this case. So that would be this chunk of code here to access param2, and then we have this chunk of code here to access param p. So that tells me whether you understand how to access a parameter that is sitting on the stack. And over here we have another access to param2. So these are all kind of the same thing that I'll be looking for. And I'll be looking for indication that you know how to push items on the stack when you're calling a subroutine, that we are calling param2 minus 1 first. So the calculation of param2 minus 1, which is this code here, and pushing it on the stack, and also pushing p plus 1, which is done here. That's important, okay? Along with the green part here. So this is the sequence of code to actually do a call. Not gonna be worth a whole lot of points, but some. To remembering to deallocate items on the stack, kind of important. And then of course the conditional branch itself is also of importance. So I'll be allocating points to basically reading backwards the conditional branch, the compare, and how you set up the registers before the compare. So that's for the outer conditional statement, and this part here is for the inner conditional statement. So those would be important. The structure of the conditional statements is also important. The then branch has a way to branch around the else branch in both cases. Okay, those are all important. And that's about it. You can see that there are some lines that are not worth any points, like how to return the value of 1. That's not worth any points because it's just loading the return value into register A. All right. So this is how this is one implementation of the subroutine. You can also use the other way, which is copying register D to register C and then move register C around to get to various items. As long as you can get to the parameters, you'll get the points for accessing the parameters. So how you get to it or what instruction sequences you use is not as important. All right. So I'm going to set up the rubric for this particular question and then start grading it.